All right, optimization means we're trying to find the max or the min of a function, and we know that's where the critical numbers occur, right? Where the derivative is equal to 0, and that will make sense. There's only going to be one critical number for each of the functions, so you don't need to go check to see if it is a max or a min. All right, so let's dig in. So if I want to find two numbers whose difference is 100, so I want to start with, say, x minus y is 100. And then just like when we were doing related rate problems, you need to make sure you don't put in extra variables. So I want the product to be a minimum. So I'm going to say product is x times y. So since this is what I want to minimize, you're thinking this is what I want to take the derivative of and set it equal to 0. So you're going to set this equal to 0 and find the critical numbers, right? Okay, but I look at this and it's got two variables. So this is where I take this, and this is called typically the constraint, and I want to solve for one of the variables. So let's just solve for x. So I get 100 plus y. So I want to substitute into this equation. So I get p equals 100 plus y times y. Okay, now since this is in one variable, I am ready to take a derivative of it. But I would suggest first let's multiply it out. So I get 100y plus y squared. Now I'm ready to take the derivative. So the derivative would be 100 plus 2y, and I want to set that equal to 0 because that's how I find critical numbers, right? So 2y is equal to negative 100, so y is equal to negative 50, so that's one of the numbers, and you're always going to have the other variable with the constraint solved for, so that gives me x is equal to 100 minus 50, so x is 50. So those are the two numbers where the product is a minimum and their difference is 100. All right, so let's go to the next one. So we're going to have a lot of physical things of perimeters and areas. Okay, so the dimensions of a rectangle, that's what we want to find. It has perimeter 100 meters. So you know perimeter would be 2 times L plus 2 times W, right? Going all the way around L, L, W, W, all the way around my rectangle. Okay, so what is it I want to find as large as possible? Again, you'll always be asked for a minimum or a maximum. And so what I'm trying to find the maximum of is area. And so I'm thinking, okay, I want to take the derivative of area and set it equal to 0. So what is the equation for area of a rectangle? Well, since I've used L and W for my length and width of my perimeter equation, I need to use those two letters in my area equation. So now we're going to sub in, and so I need to solve for one of these variables. It doesn't matter which one. So how about if I do 100 minus 2w is 2l, and if I divide through by 2, that gives me 50 minus w is equal to l. Okay, so now I'm going to put that in right there. So area is 50 minus W times W, and it's always going to be easier to multiply it out rather than doing product rule. So let's do that. So I get 50W minus W squared. Now I want to take the derivative and set that equal to 0. So I get 50 minus 2W, set it equal to 0, so 2w is 50, so w is 25. Okay, so then how do I find where the length is? So I take this, w is 25, and put it into here, and so I get L is equal to 50 minus 25, so L is 25 as well. So it turns out to be a square. You're not going to get easy ones like that where you can maybe even just see that from the beginning. All right, let me stop there and go to the next one.